Today's speaker is Professor Gong Jiangbin, who is the head of the physics department as well as the provost chair professor. He will be telling us more about the NUS physics program and how it equips students to solve complex real-world problems. So Prof. Gong obtained his PhD in theoretical chemical physics from the University of Toronto. He has also received multiple awards, such as the Institute of Physics, Singapore's World Scientific Prize and medal in recognition of his research. So Prof. Gong, please.
Yeah, thank you. Very good afternoon to all of you, and congratulations for you being admitted to NUS. Lying ahead is 4 years, 4 exciting years for university education. And I think professors at NUS, the main mission is to help you to discover your potential and to stretch yourself, yeah, so that you can dream your dreams and your dream will come true, I hope. Yeah, so today I only have 20 minutes. I don't have time for jokes and so on. So let's quickly get back to the serious matter. Why physics now and why physics at NUS? So in any case, no matter what you are going to choose to study at NUS or elsewhere, my advice is for you to aim high first, because only if you aim high, then you can take the best advantage of the quality education at NUS. Okay, and I can also elaborate more about what I mean by aim high. For example, physicists aim high as by asking this kind of bigger questions you can ever imagine. So on the slide, you see this kind of bigger questions. Yeah? So by asking this kind of bigger questions, yeah, it's more likely for us to keep motivated and to find our passion and find our true potential. Yeah. For example, you see some pictures on black hole, some pictures we take at NUS Observatory, and some pictures about our own professor on campus building future quantum computers on campus, right? So this is what I mean by aim high. So you might think, wait a second, professor yourself might not have been able to answer this kind of questions. So why are you inviting me to attack those questions? Huh? This is something you're thinking about. Yes. I didn't mean everybody here eventually can solve this kind of bigger questions, but by attacking this kind of bigger questions, by working on some smaller questions under the umbrella of bigger questions, we can hit inventions, we can advance our technologies, we can invent new research tools. That's always the case for the history of physics. Look at this, okay? On the right side of this slide, all these technologies are those things we can't live without today. All those are consequences of pushing those bigger questions. For example, optical fibers. Without good understanding of optical fibers, we don't have internet. Then what are we going to do, right? And quantum computers, of course, something I'm going to elaborate a bit more. Semiconductor devices, I will also explain a bit more. More importantly, in this process, by answering or understanding the bigger questions, we can develop soft skills that are very important to help us excel in different sectors of the economy. For example, theoretical modeling, critical analysis thinking, complex problem solving. And later on, you are going to see that's why many of our physics graduates can excel in many, many different sectors in the economy. Okay, so on this slide, you see top 10 skills our employees are looking for. Yeah, so maybe we can focus on this column, 2020. The top 2 skills are complex problem solving and critical thinking. These 2 skills are exactly what a physics training can deliver. I'm going to elaborate on that later on. Okay, so why physics now? So this is a physics first question. So in my view, lying ahead, okay, facing this generation are the following 4 critical changes, not even including pandemic. So they are this digitalization, quantum computing, energy crisis, and global warming. Yeah. So as a matter of fact, many of these are here, first of all, due to what advances in our understanding of physics. Yeah. For example, this all made possible by semiconductors, right? This Nobel Prize in semiconductor was awarded in 1950. Yeah. Quantum computing, of course, all initiated by physicists 4 decades ago. Energy crisis, we need a safer nuclear energy. We need a clean solar energy. We need so-called blue energy, that is how to extract energy from seawater. Yeah, and global warming. We all understand climate becomes more and more problem in our daily life. And believe it or not, last year, half of the Nobel Prize in Physics was awarded to understanding or modeling of Earth climate in 1960s. So this is a very important slide. As you can see, physicists are always, 30 years, 40 years, 50 years ahead of the generation in order to predict or in order to solve problems in advance, yeah, or create new opportunities for future generations. So now let me elaborate a few items here, those critical changes. For example, digitalization, the digital economy nowadays. Yes, different bigger companies or governments have alerted the public again and again. We have this serious brain drain. We have this talent gap in order to fill, in order for us to have a place in this competition in semiconductor industry. In the middle is a piece of news that made Singapore very happy because US chip foundry is setting up a new manufacturing plant in Singapore, right? So this will create many more high-end jobs in Singapore. But okay, this is a current competition. In order to really have a say in this competition, right? Look at this fact. By the year of 2030, 25% of energy consumed on Earth will have to go to semiconductor devices, microelectronics. And this is crazy. This will be severe bottleneck for future economy. So what should we do? Well, we expect that a new physics phenomenon, a new breakthrough in semiconductor physics that can help us to completely change how semiconductor devices working today. Yeah, so this type of breakthrough can, right, give yes. So look at this. This is strong evidence that physicists become more and more important in semiconductor sector. Look at this. Our professors are teaching local industry, semiconductor industry, right? They are conducting classes, in this case, for AMS sensor issue. So why is that so? Look at the courses we can offer in the physics department: nanofabrication, solid state physics, thin film technology, surface physics. Those are the key knowledge that we could use to boost the knowledge level of the local workforce in semiconductor industry. Yeah. So studying physics means you have lots of say in the future semiconductor industry, which is so important in today's economy. Now, let me speak of quantum computing, right? It was estimated 3 years from now, the total market value of investment in quantum computing is about $10 billion US. Here are a few companies, new companies like IMQ, QCI, D-Wave, aiming to build quantum computers. In Singapore, believe it or not, we already have 2 quantum computing startup companies. Yeah? Later on, you will see they are already hiring our own graduate into this new kind of technology. And on campus, if you have signed up, I hope some of you have signed up laboratory later today, you might have a chance to see lots of exciting development at the Center of Quantum Technologies, including Professor Ivan Gau's lab, who is building quantum computers on campus. Okay, now, in addition to Professor Ivan Gau's effort to address the ongoing changes in this, facing this generation, here I use 3 more examples to illustrate what kind of research NUS physics professors are doing to address issues in the society. First of all, our Professor Yen's group, they develop a highly efficient scheme to measure the level of our antibody against COVID-19. I personally have been to his lab 3 times to measure my antibody level to determine what's the optimal time to get the booster jab. Okay, so this is, you might think this is so much away from physics. That's not true. I have to say, you realize physics professor can do lots of more things than you could imagine. Second example, I just mentioned, right? We need a new kind of material. Hopefully can take us to entirely new semiconductor devices, right? That's exactly what the Professor Aliran's group is doing. They discovered a new family of materials that are more energy efficient so that our future semiconductor industry, if Okay, eventually that can lead to some devices can be more sustainable. Yeah. So, and it will lead us to some much faster, 1,000 times faster memory devices. And last but not least, in terms of energy crisis, Professor Slav and Garage group, they developed new membranes in their 2D material research to harvest energy by mixing different water streams. Now they are commercializing this. They have set up a company as supported by NUS. So physics professors are not nerdy lecturers sitting in the office imagining what is time, just like this kind of question. We do lots of practical problems also, okay? Okay, so now second question, why study at NUS? This is what I can offer: high quality teaching, conducive, caring environment, and exposure to most frontier labs and the best researchers in the world. Just now, over this morning, right, some of you already approached us asking about the research opportunities. I don't have specific answers, but later on from my slide, you roughly can taste, yes, you are given lots of opportunities to participate in the research on campus by physics professors. Okay, so first of all, we enjoy teaching. As you can see, we keep constantly improving our teaching method, and most important of all, many of my colleagues are passionate about teaching itself. Look at those pictures. So they invented all sorts of methods to improve our teaching. And because of that, over the years, many of our lecturers at the physics department, they are highly recognized by our students for their excellent teaching. So they won teaching awards after teaching awards. So imagine if you join NUS physics department, you are going to have the luxury to be surrounded by many stellar lecturers on campus. So that's true. And about the research, look at this. Those, of course, we rely on all those professors at NUS physics to conduct world-class research. So if you count the number of faces, you can easily get about 50 plus. And each year, we take in about 40 plus students as of last year or previous 2 years. So now you compute by yourself the professor to student ratio. It's extremely high. So therefore, that's why I argued just now that you have many opportunities to do research with our professors. So speaking on research, look at this. We have a Center of Quantum Technologies. Just now I got an excellent question about what quantum technologies are. It's about quantum computing, it's about quantum sensing, about atomic clocks, and so on and so forth. So this is a national level research center. Look at those, all those faces are physics professors. So even though it's a national research center, it's more or less like a part of the physics department, yeah? Okay, now second one, we have another university level center, the Center for Advanced 2D Materials. Those are the research labs you can see from the slide. We have another university level research center, Singapore Synchrotron Light Source. Professor, the director, Mark Breeze, again, is a professor of physics. Yeah, we have another factory level center, Center for I-beam Applications. Look at those bigger machines. If you have signed up laboratories, you are going to be able to directly see those bigger machines at the Department of Physics. So why are we having assembly those bigger machines? We accelerate ion beams to high energy. Then we use that to create nanostructures for applications in optics and so on. We also use those I-beams, direct hit tissues, to study how tissues respond to high energy beams, so that we eventually can contribute to the medical physics, to find the cures to cancer. For example, all those phases are our professors in the department. Okay, so our physics department is just normal, not a normal academic unit. Okay, we are across the campus. There are many people working in many different parts of physics research. So this is also something I must share with you. Since 2020, the department has attracted 5 young stars joining our department. Professor Li Qinghua, Professor Hou Wenwei, Professor Edwin Chuang, they are Singaporeans. They grew in Singapore, so they understand our students better, I hope. So in any case, you can imagine, okay, with them joining us, they bring the most frontier research ideas. They are energetic. They bring most frontier research topics to the department, so as to benefit our future students. Okay, now parents, yeah, probably that is concerned you most. So where are physics alumni doing nowadays? Yeah, So I first show you some lovely faces, just show you the diversity of the job sectors, okay? For example, medical physicist, finance analyst, production manager, senior business analyst, and so on and so forth. The medical physics because of their training in the CBA, the Center of IB applications. Yeah, another slide, again, you see more faces. I still remember most of them because most of them have taken my quantum mechanics class. Yeah, for example, King Long, and there's Yu Qian, and so on. So you see, okay, those are the jobs our physics graduate can land. Okay, probably you are not aware of this before this talk. So I choose to feature one alumni, okay, among those graduates. Okay, so this is Long Qixiao. He got his bachelor degree about 10 years back. Yeah, now look at this. He's a very important person overseeing the strategy and the business development for the Asia Pacific regime of the gas energy power sector at Siemens. Yeah? So this is what our graduates can do. Okay, now, second question. Where are our latest physics graduates doing? That's even more important. Yeah. So look at this. Those are the employers of our previous batch of physics students. They are from everywhere. Ministry of Manpower, National Youth Council, DBS, NTU, and so on, A-Star, and Great Eastern Insurance, and where is a quantum computing company somewhere? Okay, maybe the previous slide. Did you see? I might miss, but it must be somewhere. Okay, Anthropica, a quantum computing company. Yeah, Ministry of Education and US. Now, this is not all. More important message is for you to understand that a bigger portion of our physics graduate, which with this magic percentage, 28 or 29% of our physics graduate students, okay, they choose to pursue further study after graduation. Apparently, they enjoy the quality teaching, quality education at the NUS. They enjoy physics. So they decide to do more. Yeah, they must have convinced their parents in the hard way to show how lovely physics is, and they decide to do further studies. So therefore, today I hope to use a bit more time to analyze, okay, why they are such a big portion of students choosing to do graduate studies. Yeah. So, for example, this our own graduate last year, he chose to continue to do another one-year master course at NUS Physics. He loves physics. He likes our teaching. Okay, but look at this. Even way before he completed this course, he already offered a job at where? National Eye Center to cure patients. How did that happen? Look at this. Okay, that's what he's sharing with you. Studying physics at NUS is not always about the physics per se, but about the learning problem-solving techniques and the skills. And many of the modules in the course will teach them. That is, many of our physics modules will teach you how to solve complex problems. And he also said, it is remarkable. Yes, I agree that a physics student can get a job in this, how to pronounce this, ophthalmology research without any prior experience in medicine. So he's very, very happy. He asked me to write a reference letter for him 1 year ago, and very quickly after that, he got the job. Yeah. Okay, so then this is another example. Yeah, so Joe Ong, he got his bachelor degree from NUS. He chose to continue. Where? This time, he decided to have some overseas experience, which is fine with me, and he got a PhD in astronomy from Yale University. Look at what he's saying. The physics department at NUS permitted me to build a firm foundation, analytical and computational thinking. Look at this, these comments are echoing, right? They are very much similar comments. Skills on which I continue to rely heavily in my current position as an astrophysicist. Did you sense the kind of proud when he's writing this sentence? I'm an astrophysicist now, yeah, from Yale University because of the education I received from NUS. This is another case, okay, to illustrate the versatile success pathways of our own graduate. So this case is Joe Wu. He's now CTO at the company BioMind. This company is very successful. They are now giving scholarships to CHS students. Yeah. So a few months back, I was meeting his team, and to my great joy, guess what happened? Most of the members he brought to the meeting are our own physics graduates. It's like a reunion of my quantum mechanics class in this meeting. So why this company is hiring so many physics graduates? Because we need a physicist to generate physically consistent data to feed into machine learning algorithms. And this can speed up AI so that we can find solutions to complex problems. Okay, so this is another example. This time for convenience, I grabbed my own student, okay, Tan Dayao. He did a PhD with me after bachelor degree at NUS. And then he did 3 years of air traffic control research at NTU. Think of this again, the kind of versatile trajectories that a physics graduate can land on. After that, now he's outstanding mentor at SUTD. Another simple example is Lu Yonglam. Okay, he took my quantum mechanics class 10 years ago, 11 years ago. Yeah. Then after that, because of some MOE bond, he taught for secondary school for 4 years. Then she comes back. She loves our teaching. She enjoys physics, right? So she did a PhD with us. After that, now she's a lecturer at NUS. So this is what she's sharing with us. Don't fear failure. It is a primer for future successes. Dare to explore and step out of your comfort zone while in university. So that's also is something I want to tell you. Aim high. Don't fear on the failure. Yeah, you have to stretch yourself to aim high. Okay, this is another example related to this research opportunities. Okay, so this student, So Tampen, during his second year, he already did a research with me. He wrote 2 quantum physics papers with me. How outstanding he is. So I thought he will continue to grow, eventually become professor in quantum physics. But that's not the path he eventually took. Not because I'm not good enough, it's just because all diverse possible pathways for him. He decided to do a PhD at the Mechanical Biology Center at NUS. Now he's a professor at Westlake University to study biophysics on a combination of biology and physics. Okay, so this is another situation. Now, finally, we have a quantum physicist. He did his undergraduate degree 2014, and after that, he did a PhD within 3 years. Now he's becoming assistant professor at Saudi Arabia. Okay, last but not least, this is again our own student, bachelor degree 2015, PhD 2021, and he's scheduled to come back to us as a faculty member soon. Okay, so I hope this is convincing enough to show you that physics graduate can land on diversified pathways. So future is uncertain as the world is changing really fast. Great value of physics training is certain, and there are many successful pathways. So key take-home messages. Physics handle bigger questions. We challenge ourselves, and therefore we grow ourselves. So we dream our bigger dreams by asking bigger questions. Second, physics is vital to face critical changes of this generation. So if you want to make a difference, physics could be a right subject for you. And physics offers you essential skills for a career. There are many jobs in Singapore, but for a satisfying career, for a career that really lasts long, yeah, then physics is the right subject to prepare you for a good career ahead. Okay, so this is our physics Telegram channel. From there, you can see lots of ongoing activities in the physics department. Yeah? For example, those interesting posts you might find interesting. Okay, so yeah, I have to conclude. Thank you very much.